Monitoring for potential outflow boundaries is critical because firefighters need to know of the associated wind speed increase and change in wind direction that accompanies outflow boundaries. Let's begin with the GOES 16 imagery, 3.9 micron band in the upper left panel, the visible imagery in the upper right panel, the fire temperature RGB in the lower left panel, and the IR imagery in the lower right panel. First, let's identify the fire of interest. Although we see a hot spot located here, we're going to focus on the hot spot further to the west in this location. This is associated with the Lake Christine fire in western Colorado. In the visible and IR imagery, we observe convection over this region, which led to the development of an arc-shaped line by later in the animation. This is the outflow boundary that developed from the aggregate of convection. Let me go ahead and stop the loop to identify that outflow boundary. So we can see early indications of an arc line right here. Go a little bit later in time, and you can see it located approximately right here. So it's moving towards the west, towards the Lake Christine fire. This is occurring near sunset. Therefore, we're losing light in the visible imagery. The IR imagery is taking higher priority as we approach darkness. Now let's look at radar data from the nearest available radar located at Grand Junction, located right here. The radar data shown is from the half-degree tilt, reflectivity in the upper left panel, velocity in the upper right panel, correlation coefficient in the lower left panel, and for comparison purposes, I showed the SIMS natural color RGB in the lower right panel from GOES 16. The convection in the reflectivity is not that strong. However, in this dry environment, it's sufficient to generate outflow boundaries. Multiple storms combine to form an outflow boundary that forms in a north-south oriented arc line and moves westward. The signature is somewhat subtle from the radar perspective, but when combined with the satellite data, provides a clear indication of the location and movement of the outflow boundary. The outflow boundary becomes better defined in radar later in the animation as it gets closer to the radar site. At the same time, we are losing detection of it in the natural color RGB as we approach sunset. This is a great example of data fusion, with radar data increasing in priority as visible imagery from satellite is decreasing in priority. The power of the combined data set offsets limitations associated with sunset and radar range. Surface observations are important as well, but keep in mind the elevation may vary considerably between sites in complex terrain regions such as here. The outflow boundary caused wind gusts in the 40 to 50 mile per hour range and led to rapid fire spread as well as unexpected fire spread direction. Active monitoring for potential outflow boundaries and communication with firefighters on scene is critical.